does this mean? Consecutive integers? What do I mean by consecutive integers? Can you give me an example of two consecutive integers? What do you think? 3 and 4. Is that two consecutive integers? What about -3 and -4? Are those two consecutive integers? Yes, because integers can be negative, right? Okay. What if I ask you to name two consecutive integers, and I tell you the first one is called x. What's the second one called?
Y.
Nope.
X again.
Kind of.
X1.
What about 1?
Raised to the
Not raised to the 1.
1x. I don't know. 1x is just x.
X plus 1? If this was 3, how do we get to 4?
Plus 1.
We add 1, right? So if the first integer is called x, the second integer would be called x plus 1.
Oh, I see.
Does that make sense? And if I tell you two consecutive integers have a sum of 13, could you find both integers?
Yes.
How would you find them? Well, if these are the two integers, why do you want to add them together? Because I said sum, right? Okay? So if I add these together, and what I say, it's 13? Okay? So now how would I solve for these two integers?
Combine like terms?
Yes, like you're looking at me like super confused because you're like, this can't be this easy, right? It can be.
But probably, yeah.
But how many times in this class have we talked about two consecutive integers?
Never.
Never, right? So we're going back over it today, right? So x and x is what?
6 and 7. 2x.
2x plus 1 equals 13.
Minus 1.
Okay, from both sides, right? So 2x equals
12.
12.
And then divide by 2 both sides. And then x equals 6.
X equals 6.
6 and 7.
Right? Now, is that one that you could have thought in your own head and figured it out?
Probably.
Probably yes. Okay? But I wanted to get the math behind it so that we could understand what's happening, because are they all that easy? No. Okay? Now, here's something that they might do. They might say the sum of two consecutive integers is 13. What is the second integer?
Whoa. Oh, wait, that's 1.
It wouldn't be 6,
It would
would
be
it?
7.
It would be the 7. It would be the x plus 1,
Yeah.
right? So what I want you to do is, if you get a consecutive integer problem, first of all, make sure you know which one it's asking for. Okay? Because are they going to try to trick you?
Yeah.
Yes, they are. Okay? Now, sometimes they might not ask for two consecutive integers. Sometimes they might ask you for two consecutive even integers. So that's the next thing I want you to make sure to look. Are they asking for consecutive integers, or are they asking for consecutive even integers? Well, if the first integer is x, what's the second integer?
X plus 1.
Give me an example of two consecutive even integers. 2 and 4,
Oh,
right? How do you get from 2 to 4? You have to add 2, right? So the first one is x, and the second one is x plus 2. Does that make sense? So I'm going to tell you two consecutive even integers have a sum of 14. I know you can figure it out in your head. I don't want you to. I want you to do the math. Now, on the test, if you can figure it out in your head, good for you, right? But we're practicing our math right now. So what am I going to do? Add them together because I want the sum equals 14. X and x, 2x plus 2 equals 14. Minus 2 from both sides.
2x equals 12. And then x equals
That seems familiar, right? Only because it just happened to be above in the problem above. X equals 6. So what are the two integers? 6 and 8, right? We didn't write them up here. What are they up here?
6, 7.
6 and 7, right? 6 and 7. Now, is there a way we can check that?
Yes, you plug them in.
Well, if the sum was 13, add these together. Is that 13?
Yeah.
Add these together. Is that 14? Yeah. Okay? Now, are you ready for the tricky one?
Good.
Yes, because you're not going to let it trick you, are you?
Right.
Okay? Let's see. 2 consecutive odd integers. 2 consecutive odd integers. That's all I'm telling you at the
3
beginning.
and 7.
If the first one is x, what's the second one? Can you give me an example of 2 consecutive odd integers?
3 and 7.
3,
3 and 5.
3 and 5, right? 3 and 5. Guys, how do you get from 3 to 5?
Or 2.
Do you see why it's tricky? Because is 2 an odd number? No, so that throws people off sometimes, doesn't it? But if it's an odd number, to get to the next odd number, you have to add 2. Does that make sense? So the sum of I'm gonna even make it trickier. You ready? The sum of 3 consecutive odd integers is
X plus 2 plus x plus 4.
So is this right now? It's not, is it? Because I just threw on a 15 to make sure I would remember the number. What are we missing? How many integers did I say there were?
30.
3. So this is the first one. This is the second one. What's the third one?
X plus 4.
Uh-huh.
Yeah.
X plus 4. So I've got x plus 2 plus x plus 4, and that has to equal 15. Does that make sense?
So you have
3 consecutive odd integers. Here's the first one. 2 away from that first one is the next one. And 4 away from that first one is the third one. So x plus x plus x, 3x
plus 6
plus 6
equals 15
equals 15.
minus 6 gives you 9.
So 3x equals 9.
Then you divide by 3, and then you get x equals 3.
So what do you have to be careful of right now?
Checking it.
We're going to check in just a minute, right? We're going to write down our 3 integers, but what do you have to be careful of right now? What is it asking for? Remember that? Which term is it asking for? Is it asking for the smallest one? Is it asking for the middle one? Is it asking for the largest one? Does that make sense? So what are my 3 numbers now?
3, 5, and 7.
3, 5, and 7. Does that make sense?
Yep.
So what do we call the first integer if we're talking about consecutive integers? What do we always call it? X. Okay? Depending on if we're talking about just integers or even or odd integers, tells you what your second term needs to be. But base it off of your first term. Does that make sense? If it's just consecutive integers, it's just 1 away. If it's even or odd, those are both 2 away from the original number, aren't they? Okay? Any questions about that? Okay. The next part of our TSI work for today are exponents. But, what am I going to say? Can you use your foldable on the TSI?
No.
No. Okay? So I know we've done exponents even in Algebra 2 already this year, but we're going to go back over them today because of the fact that every other time we've done exponents, I let you use your foldable. Right? We can't. We can't use foldables on TSI. Okay? So I'm going to make sure to go back over these rules with you real quick today just so that they're in your head. Okay? Product of powers. When you're multiplying like bases, what do you do with the exponents? You add them. When you have a power to a power, what do you do with those exponents? Multiply them. If you are multiplying 2 numbers in parentheses and raising that to a power, which one of those gets the power? Both. Okay? If you're dividing 2 numbers that each have exponents, what do you do with those exponents? It's like bases. You subtract those. When you're multiplying, you add. When you're dividing, you subtract. Yes? When you're dividing two numbers that are both being raised to an exponent, which one is raised to the exponent? Both. What about negative exponents? Are we allowed to have negative exponents? No. Okay. If you have a negative exponent and it's in the numerator, where does it want to go? The denominator. And if it's already in the denominator, like this one, where does it want to go? To the numerator. When it moves where it wants to go, it is no longer negative. Do you remember that? Okay. And then, remember our super amazing stuff? Anything to the 0 power is what? 1. Anything to the first power is just itself, right? If you have a fractional exponent, the numerator is the power, just like we've always dealt with, but the denominator is the root. Okay? Nothing I've seen has made me think there's going to be rational exponents on the TSI, but just in case. Okay? Do you have any questions on these exponent rules? You good with that? Okay? Now I know that this is our algebraic day, but because I wanted to make sure to cover at least everything once, let's talk a little bit about probability. I know we had a probability day, but we are mostly dealing with that probability that we dealt with. Okay? So let me ask you this. Have you ever seen a die? And this is a 1, and this is a 2, and this is a 3, right? What's on the back side of the 1? Do you know this? It's a 6. What's on the back side of the 3? The 4. And what's on the back side of the 2? The 5. How do I know that? Opposite sides of dice are supposed to add up to what? 7. Right? 1 and 6 are opposite, 2 and 5 are opposite, 3 and 4 are opposite. Right? It helps balance the die better somehow or something. I don't really know. I just know that's how they are. Okay? So you know there's 6 sides though, right? What's the probability that I roll a 4? 1 out of 6. What's the probability that I roll a 3? 1 out of 6. What is the probability I roll an even number? How many even numbers are there? 2, 4, and 6, so that's 3 out of 6, which is what you're saying, simplifies to 1/2, right? I just want to make sure we didn't lose anybody. Okay? What's the probability that I roll a prime number? So we got 1, 2, 3, 4, 5, and 6. What's not prime? 6 and 4. And? 1's not considered prime. It's prime if it's only divisible by itself in 1. And that's 1 and 1. And so 1 is a weird number. So we just ignore it a lot of times. Okay? So how many prime numbers are there on this die? 3 out of 6. So 1/2. That's Abraham Lincoln. Okay. What's the probability I flip this coin and get heads? 1 out of 2, because that's the only possibilities, right? Now, technically, is it the only possibilities? No, because we could always flip it up and it could land right on its edge. But how many times did it ever do that? So rare that we don't even talk about it, right? Okay. Let's see. I have a drawer. Here's a drawer. That's a terrible drawer. Please don't judge my drawer. Ignore that part. We'll just shade that part so you can't see that. And I have a little drawer pull right in the front. In this drawer, I have a bunch of socks. And I have 6 blue socks. And I have 5 red socks, because I always have 1 red sock that just is lost. And 4 green socks. What's the probability that I reach into this drawer with my eyes closed, because you know we do that kind of stuff all the time, and I pull out a blue sock?
6 over 15.
6 over what?
16.
How,
6 over 16.
how do you decide what's in the bottom? Like the total number of socks. Well, what's 6 plus 5?
11.
Plus 4? 15. Does that simplify?
Yes.
It does. They're both divisible by 3. So it is 2 over 5. Okay. What's the probability that I draw a blue sock and then a red sock? And I don't put the blue sock, or I don't put the first sock that I draw out back.
So 11.
So first of all, what's the probability I get a blue sock?
2 over 5.
2 over 5, because we just did that.
But then it's going to be 5 out of 14.
5 out of 14, right? And because of that word, what do I do with these two numbers? Multiply. Now if it said blue or red, what would I do? Add. Okay, but I need a blue sock and then a red sock, not putting the first one back. Yes? Any questions about that? Does it change the probability if I put the first sock back? Yes, it does, doesn't it? Okay, because then it's 2 out of 5 divided by 5 out of, or times 5 out of 15, which is 1 out of 3. Does that make sense? Okay. Any questions? Feel good about probability? Rolling die, tossing coins, drawing clothes out of drawers or closets are typically the kinds of problems that you see. Are they the only kinds of problems? No, they're not. But I thought I would just give you general overview. Does that work? Okay, any questions?